Let's go on page 139 when we're done. Okay. We talked about sequences last week, right? Like a pattern of numbers that we had. And we had arithmetic and geometric sequences. So today we're going to start talking about series. So what a series is the sum of the terms in a sequence. So a sequence is the actual list of the numbers, or an equation that will get you that. And then a series is the sum of those. So an example of a sequence would be like 2, 4, 6, 8. The series for that sequence would be you adding up those four numbers, which would give you 20. Okay. Or if I had something that looked like 4, 8, 12, 16, ... and I kept on adding, I kept on going, and then I added them all up, what do you think that's going to give me? Infinite, yeah. So it's not only an infinite sequence, but it's also an infinite series. Then if I have one, and we'll talk about why this happens later, but just go ahead and give this to you now. If it looked like that, okay, and it keeps going, this isn't going to get me to infinity. Like I'll have an infinite amount of terms in my sequence, but the series is actually going to add up to give me 1. Again, the why behind, I don't expect you to know that right now, just we'll talk about the why later on, but it's just part of that. Okay. All right, so we can have also just partial sums, because maybe it is an infinite sequence, but we don't really want the sum of the whole thing. So a partial sum is the sum of specified number of terms in a sequence. So maybe it's not every single term in the sequence, just a specific number. And so this would be a capital S with a subscript N. So the sum of however many terms. Okay. So we are going to find, it says find the partial sum for each of the given, for each given sequence rather. So if we do this, here's what it gives me. I want S of 7. I want the sum of the first 7 terms. Well, this gives me the first 1, 2, 3, 4, 5. So I need to find 6 and 7. I don't necessarily need a rule for it. Nobody's asked me for that at this point. I just need to find 6 and 7. So we're adding 4 each time, right? So this would give me then 22 and then 26. Okay, so then the S of 7 then is equal to, I would add up all those numbers. And something you're capable of without a calculator, but you got the calculator, you can just add them up, it's fine. Ed, are you doing it without a calculator? Okay. Now you do. What is it, Eddie?
Hold on, I'm still getting the 96
Okay.
and 14. Oh, that's 50 and 72.
Okay. All right. 98.
Okay.
Yeah. Yeah, he got it. He was calculating. It's all good. Okay. So
50 plus 22 is 72.
yeah, he was doing it in pieces. I was following him. He was good. All right. So then number 4, I want S, the sum of the first 3 terms. So I don't have to find any extra ones. So you can do that one without a calculator, Eddie. Come on. You can do it. I'm challenging you here.
2. Wait, isn't it 2?
It's 3, the first 3 terms. It is not 2. What you got? Okay, but you got to give it to me as an improper fraction, but yes. 13 over 9. All right, so y'all got the idea of the partial sums, right? We'll do one of these. So those actually gave them to us. Let's see. Let's do number, we'll just do this one, I guess. Oh, crap. All right, we'll do this one. So I've got to find the first 5 terms in order for me to do this, right? And it gives me a sub n is n cubed. So it's going to be 1 cubed, and then 2 cubed, then 3 cubed, 4 cubed, 5 cubed, right? So what is 1 cubed? 1. What's 2 cubed? 8. What's 3 cubed? 27. Good. 4 cubed? 64. And then 5 cubed? 125. You just have 5 quarters and it's 125. Good. And then you can add those up. So the sum of the first 5 terms. Go ahead. No, you cannot. That's not a dumb question. That's a good question. Because of your exponents, you have to do the exponents before you add the please excuse my dear Aunt Sally. All right. So what do we get? 225. Good. All right, so y'all got the hang of that? So we had to find them, and then we had to add them up because we wanted the sum. We had to find the first 5, and the other ones they just gave them to us. I just want to make sure you know the difference there. All right, so let's talk about notation and how this stuff works and what we're really doing here. So this big Greek letter, anybody know what that big Greek letter is? When you see one what?
Test your vision.
Oh, yeah. It's not one of those. Ethos is not one of the numbers or one of the letters. It is a Greek letter. It's a capital. This little letter here or big letter here is sigma. So this is what's called sigma notation. You see that a lot. It's summation notation. Anytime you see that mathematically, it means you're taking a sum. Okay? So this is the sum of the terms from 1 to 5. It doesn't always have to start at 1. I could have the sum of the second term, you know, all the way to the 5th or whatever. So this is the last term number. And this is the first term number. Okay. So this right here would just be whatever you're trying to use. So this is just the formula for the sequence. Really? No, I have no idea.
That means at 20 yards, it looks like it's 420.
Interesting. So why don't you have on glasses? Where are your glasses then? Okay. So we want to find the sum of the series above, right? So if it's 2 times n, then we're going to take 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. Okay? Because it says, find the sum of the series above. So we're finding the sum. This is what this means. I want the sum of this sequence from 1 to 5. So these are my n numbers. It's 2 times n. Okay? So then this is 2, 4, 6, 8, 10. And when you add those up, look, 2 and 4 is 6, 6 and 6 is 12, 12 and 8 is 20, and 10 is 30. Sometimes it's easier without a calculator. Good. All right. We all good? Got summation notation down? All right, let's flip it over on the back here. So I want, let's see. Let's start with number 11. Okay? I want the sum, but I'm not starting with 1. It is starting with 2. See how it goes from 2 to 8? Okay? K is equal to 2 from 2 to 8. So we're going to say that this is going to equal, well, K squared, I'm starting with 2. So this is 2 squared minus 2 plus, and then we're going to do 3 squared minus 3 plus 4 squared minus 4 plus 5 squared minus 5 plus 6 squared minus 6 plus 7 squared minus 7 plus 8 squared minus 8. Does everybody understand where I'm getting my numbers from? I'm starting at 2, going to 8, substituting in for k. I'm on number 11. Is this why you're so confused? Sorry, I jumped to number 11. Okay. So what this really gives me then is, well, 2 squared is 4 minus 2 is 2. 9 squared, or 3 squared is 9 minus 3 is 6. 16 minus 4 is 12. 25 minus 5 is 20. 36 minus 6 is 30. 49 minus 7 is 42. 64 minus 8 is 56. Now look at this. 2 plus 6 is 8. Plus 12 is 20. That's 40. 70. So this is 112, right? 112, and then I can add the 50, so that's going to be 162, and then what plus 6 is 168. It's not that bad. You could use a calculator, but it's not always that bad. So it's safe if you have it to check yourself, you know, that's fine. But all right, questions about that? What? Are you still lost? No, that's okay. All right. All right, what questions do you have? All right, y'all do number 14. It's not as bad as it looks. I'm actually giving you that one because it's really not that bad. But I would definitely use a calculator on this one when you need to at the end. Yes, that means you start at 3. Yes, that's why I started at 2. No, I know what you meant. When you're doing something like this, although some of these reduce, if you're going to add them up on the calculator in the end, you don't have to worry about reducing. So, right now, like at the end it would need to be reduced, but you wouldn't have to worry about that right here. You can actually even see the pattern better if you don't. Yeah, it's a weird number. You get what? Is it 2021 over 560? Yeah. All right, questions about that? All right, let's look at, let's see. We'll do 15 because I want to do one of these. I think 15 would probably be better to do. So this, we have, do what? Well, this, like your final answer should be, you can reduce. I'm just saying you don't have to. And so if you did, sometimes like if you reduce wrong or something, you're just hurting yourself. But since you're about to put it all on the calculator, you can just let the calculator take care of it. It's not wrong if you do reduce. It's just one less thing you have to do. But at the end, it should always be reduced. All right. So let's look at 15. So I've got this negative 9/4 out front. So what that means is this just stays out front. Negative 9/4 times, and then I substitute this in. So here I am starting with 1. 1 squared is 1 times 2 is 2 plus 7 is 9. Okay? 2. So 2 squared is 4 times 2 is 8, plus 7 is 15. Okay, so then I do 3. 3 squared is 9, times 2 is 18, plus 7 is 25. Okay, so that was 1, 2, 3. So now I do 4. 4 squared is 16, times 2, 32, plus 7 is 39. Plus, then that was 1, 2, 3, 4, 5. 5 squared is 25, times 2 is 50, plus 7, 57. And then 6 squared is 36, times 2 is 72, plus 7 is 79. Okay? And then right now in your calculator, you can put all that in together. You basically just have to find the sum and then you multiply it by negative 9/4. That's the only difference there. So you have to actually do the sum first. But you can type all that in your calculator just like it is. Yeah, well, you get negative 9/4 times 224 if you do it separate. Or if you do it all at once, in the end, you should get negative 504. Yeah. What questions do you have? Pay attention to the numbers so that you're starting with the correct one, that you're substituting it into the right place, you're using the right amount of them, all that good kind of stuff. Okay? No units. All right. Okay. Why? Because we're going to get through both of this, so maybe I can give you some time to work. Yeah. It's not inappropriate. All right. So this is going on 140. I know. It's not inappropriate. So we talked about basic series. Now we're going to talk about an arithmetic series. Remember, there's arithmetic and geometric of this stuff. So those are just basic series in general. Here's a more specific arithmetic series. So what an arithmetic series is the sum of an arithmetic sequence. How can you identify that you have an arithmetic sequence? Well, you look at a series of... Okay, what kind of trend? Like what's happening in there that you know that it's an arithmetic sequence? What's constant? I don't know what you mean by trend mathematically. The common difference. Good. The common difference is constant. Where the geometric is the common ratio, right? Where you divide. But for an arithmetic, it's the common difference. Okay, good. So if I want to find the sum of an arithmetic series, right, I'm going to use the following formula. S sub n is equal to n times a1 plus a sub n all over 2. Okay? So I'm going to find those things either from the sequence that I have itself, or maybe if it gives me the rule, I can use that. Right? N is the number of terms. A sub 1 is the first term. And a sub n is the last term. Okay. So I want you to think about, let's see, maybe I'll talk about that when we get to, yeah, we'll talk about it once we get to along the back. All right, so let's look at this. We got some examples here. It says, find the indicated sum for each of the arithmetic series. Now, again, it tells us it's an arithmetic series, but if we didn't know that for sure, because they'll be mixed up at some point, if it just said find the sum of the series, we'd have to see what happens. Well, here, our common difference, we're adding 3, we're adding 3, we're adding 3, right? So that's how we know for sure that it's an arithmetic series, right? So if I want to do this, remember I'm going to use, I'll rewrite it over here. This S sub n is equal to n times a1 plus an. Oops. Over 2, yeah. Made a small parenthesis there. Okay, we good? So then I need to find a1. Well, what's a1 here? a1 equals 7. I need to find a18. Now, do I want to list out 18 terms? No, I do not want to list out 18 terms, right? Instead, what I want to do is we can use that little rule that we had. Remember that to find an, it's equal to a sub 1 times n minus 1, right? Plus what? Oh, I have the wrong thing. That's D. I put the wrong thing. I was like, I'm writing the wrong thing down. Oh, goodness gracious. D, and this is A1. I know, I had it backwards. I'm sorry. So if I do that, I can find 18, right? So this A18 that I need is equal to the difference, which is 3, times N, which is 18 minus 1, plus that 7. So it's really 3 times 17 plus 7. What is that going to give me? Oh, I totally have the wrong answer here. It is 58, but I have the right answer, then I guess I wrote down the wrong thing. Okay, good. It is 58. I wrote down 18 and then instead of 18 minus 1 on my notes, but I guess I did it right. I just didn't write it down right. Okay, so now I have that. I have A18. I have A sub 1. So I have this part of this part. N, what's N going to be? N, yeah, N is actually 18, and that can be confusing, so be careful with that right there. And so then when I do this, my S of 18 that I want is equal to 18 times 7 plus 58 over 2. All right. So I don't have to let them all out like that, and I get S of 18 equals 580. Okay. What questions do you have? Anything? I may not like your question. What's the question? No, you cannot. Skip. All right. Number 2. I skipped you. All right, y'all work on number 2. Find A1, find your A35. Think about what we just did. See if you can work through this. No, you may not. You work on this one. You're not even on the, do that problem. I did. I thought you were in the wrong place. What's your common difference on this one? Good. Negative 8. Which one? The one you're supposed to be doing. Why am I finding A? Oh my gosh. I don't want A of 50. 35 is what I meant to do. I'm just writing the wrong things in the wrong places. Negative 3010, yes. Negative 3010. You're about to say next year. All right. Are we good? What questions do you have? All right, let's jump to number 5. So I want the sum from 1 to 10, and I've got 6k plus 1, right? In order to do this, I need S of n, that's equal to n times a1 plus a sub n all over 2, right? So the things I need n. What is n going to be here? $10, because I'm going from 1 to 10, so I'm going to have 10, right? Okay, I need to find a1. I do that by doing 6 times 1 plus 1. So that's going to give me 7. Here, since they already gave me the rule to find a10, that's going to give me 6 times 10 plus 1. Which is going to be 61. So when they give us the rule, we don't have to come up with the rule ourselves, which is basically what we were doing there. So now that I have all these pieces that I need, I want the sum of the first 10. So that's equal to n times, no, oh my gosh, I already have n, what is it? 10. 10 times 7 plus 61 over 2. So what does that give me? Y'all have a calculator. Give me a break. 340. Okay. All right, what questions do you have? We understand what we're doing here? All right. Flip it over on the back, and we're going to look at number 9. Okay? Number 9. Now here I need n. What is n? What do you think? Is it 17? Do I start at 1? I'm looking at 9. So is it 17 minus 4?
No, you start at negative 4. What? Negative 7.
Where you start, it's not negative 4. It's 4. It looks like negative 4 up there. Okay, so final minus initial. So right here on number 7, that would be 6. I would have 15 terms. If I'm going to 1 to 16, do I have 15 terms? No. We are talking about 9. That's where we start. Well, yeah, but we have to figure out what n is also. I'm not asking what A4 is yet. We'll get there. Is it 14? Why would it be 14? What are you thinking?
It's right. That's what she's asking.
Because you subtract 1 and the other. Okay, so listen, if you're thinking final minus initial, right, then that would mean here is 16 minus 1 and you get 15, and that's not right, right? But how many what would n be on number 7? It's an easy question. It'd be 16, right? Because I'm starting at 1 and I'm going to 16, so there's 16 terms, right? So in order to find n, it's actually the last minus the first plus 1. You have to add 1. So if I do 16 minus 1, that's 15. I add 1, I get 16 back, right? So 17 minus 4 is 13 plus 1, n equals 14. Because think about it, you start there. You have to count that one. You can't subtract it out. Okay? So when it doesn't start at 1, you don't get to just use that top number. You subtract them and add 1 every time. Okay? So now what I need to do that sum, right, of 14 terms, but it's not the first 14 terms, that's equal to that n times a sub 4 plus a sub 17 all over 2. That's what we're going for there. So that means I need to find the 4th term, which is going to be 5 times 4 minus 27. And I need the 17th term. So a 17 is equal to 5 times 17 minus 27. So what did you get for the 4th term? Negative 7. And what did you get for this term? 58. Okay. And then you substitute it in. So you're going to get S of 14. It's going to be equal to 14 times negative 7 plus 58 over 2. So what do we get in the end then? 714? I don't think so. 357, yeah. Did you use negative 7? Yeah. Plus 58? Oh, okay. Well, that's the same thing. Yeah. So 51 over 2 times 14?
No.
Oh, well, did you say 714? That's twice as much. That's why you didn't divide by 2. Okay. I wasn't even thinking about the number you said. Okay. Yeah. All right. 357. All right. We good? Okay. So you get the same idea. So what would n be on 10? We're not going to do it, but what is n going to be? 46. Yeah, because you got 38. N is equal to 38 minus 3 plus 1. So n would be equal to 36 on number 10. Well, it's the same thing, but so what would this be? What would n be here? 19. Be 19. So make sure you're paying attention to that and you're not just subtracting and getting that confused. All right, so let's look at these here. We'll do number 11. It says, Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles the third day. If this pattern continues, find the total distance she ran after 60 days. So that means we want the sum of the first 60 days. We're not going to have to work out all 60 days, okay? First of all, n is what? 60. The first term is 2.4. Is this an arithmetic sequence? Like, do I have 2.4? Yeah, 0.15 every time, right? So that difference is 0.15. I need the 60th term, right? So the 60th term is going to be equal to the difference, which is 0.15, times n, which is 60 minus 1, plus the first term, which is 2.4, right? It's not that bad. So that means then that the 60th term, what would that give me? Okay, give me the decimal. That's good, but should be 11.25. Okay. Okay, 11.25. Okay, so I have found the 60th term. I have found what n is. I found the first term, and this is what I'm looking for here. So S of 60 is equal to n, which is 60, times the first term, which is 2.4, plus the last term, which is 11.25, all over 2. So figure that out there. And then we can say the total distance ran after 60 days is how much? 409.5 miles. All right, what questions do you have? All right, on your assignment, you are only doing the odds. Okay, so I'm going to give you the assignment. You only have to do the odd problems because they're kind of the same over and over again. I want you to have to do a bazillion of them. All right, so go ahead and glue or tape these in.